I want to introduce some ideas that are new in JavaScript ES6. I guess they're not really that new anymore, but maybe new to you and helpful for the JavaScript that we're going to be writing in the course this semester. I'm going to show this in a little bit different way than I have in other talks. I'm going to use what's called a Jupyter notebook. If you're not familiar with this idea, it's basically a web browser-based approach to giving you access to kind of an interactive interpreter that you can use to both create documentation and to experiment with code and so forth. It's initially from the Python ecosystem, but it's been adapted for other languages, including R and JavaScript and elsewhere. You can find it at Jupyter. It's the PY in the Jupyter name is a dead giveaway that it's from the Python ecosystem, initially at least. But you can find it there. You can see here from this screenshot that you can use these notebooks to create kind of interactive documents that can include graphs and charts and can have code in them that can be executed on the fly. Other bunch of other languages. They support over 40 programming languages, they say right here. It's an interactive approach to being able to do computing. You can even define, as this illustration shows with the Lorenz attractor, kind of a way of putting in user interface widgets to allow you to dynamically change the visualization. It's something that if you are part of the data science minor or interested in that minor, that we use Jupyter notebooks in that course to make it easier to construct visualizations. So it's just a different paradigm for computing, interactive computing that I feel like you need to be aware of. So I'm going to use the JavaScript implementation of the notebook to talk about some of the new features of JavaScript. So you'll get a sense for how that works. So here's the basic Jupyter framework. You can see here in the body of the notebook, there's both there's different cells that appear in here, and you can select the cells. That's actually how it shows how to hide them. But these can contain either Markdown for text, and you can see here that this cell that I'm in right now is written in Markdown. If I click in here, you can to edit this, you can see this is just an ordinary Markdown chunk, right, where the sharp sign means it's a header, and then an ordinary paragraph just shows up as a paragraph. And when I hit Shift Enter, it evaluates that Markdown and puts the resulting HTML back in its place. So you can very easily create these little segments, or cells they're called, and put Markdown in them for documentation, but you can also put code in them. So if I go down to this cell, you can see that this is actually a live coding development environment is sort of overstating it, but you can put code in there, and more interestingly, you can evaluate that code on the fly. So just like when I'm in a Markdown cell, if I hit Shift Enter, it runs the Markdown processor and gives me HTML. If I'm inside of a code block and I hit Shift Enter, it runs the code. So you can see that the output from this section comes out here in the next chunk of the notebook. So that's kind of how you make use of these notebooks interactively to try stuff out. So I just thought, again, this is a really convenient paradigm for kind of prototyping and experimentation, and not having to spin up a complete development environment and build complete programs. You can have kind of little code snippets. It's not super great for like engineering some large solution where you're still going to use traditional programming techniques, but for more exploratory work, or as I mentioned before, especially in data science, this gets used a lot. Okay, so the first thing I want to talk about with regard to JavaScript is the idea of a template literal. If you've done any JavaScript in the past, you've probably made use of the string concatenation operator. So how do you taking multiple strings and sticking them together to make a larger string. So in the past, we've built complex strings using string concatenation, but that's kind of clunky because you've got to worry about spacing, and you got to worry about, do I add a space at the beginning of this string, at the end of that string? You've got to switch back and forth between string literals and the value of variables. It can just be sort of painful. So template literals are a way that JavaScript has addressed that issue. So here's a little example. I've created an array called customer list, and it's got two objects in it. Fred and Zelda Ziffel are here in the customer list, and what I'm trying to do is print out a more human readable version of that customer list. And as I showed you before, I can evaluate this code, and what comes out is the output here from the console.log statement. So we can see it says customer Fred Ziffel since 2008. Well, so each of these strings is being constructed by using string concatenation. So it's a little bit verbose here, but I've got string equals, and then here's literal customer, and I've got to put a space in there in order to have the customer's first name not squish up against the word customer. And then I'm doing a concatenation of customer.first. So I'm doing this inside of a for loop, right? So I've got I'm iterating over the customer list and assigning each object in that list to this customer variable. So plus customer first plus a space plus customer.last. So I get Ziffel plus a space and a paren and since and another space, and then customer.since grabs the year and then closes things off with a final close paren. And after constructing that string, then I'm outputting the result using a console.log statement. And you can see what comes out here for both Fred and for Zelda. A couple of other things to notice here. So this of construct is the preferred way of iterating over a list if you're going to do it explicitly in a for loop. So use that instead of in. And then let is a new keyword in JavaScript that is almost always used in preference to the old-fashioned var prefix. So anytime you're trying to define a local variable, use let instead of var. One other thing that shows up here in this example is that in addition to, let me clear this output here. Oops, sorry. Clear output. I want to reevaluate this cell again, so I'm just going to hit Shift Enter. And you can see I get those two strings from these console.logs, but I also get this kind of unexpected undefined result. That's actually the return value from this little chunk of code. Because I'm not really returning anything explicitly, the default return value is going to be undefined, and that's what shows up down here. Whereas if you write something here that's going to return or that evaluates an expression that returns a value, at the end of the code block, you'll get that value showing up here in the output. Okay, so this works, but it, as you can see, sort of clunky, hard to get right the first time. So what JavaScript has introduced is the idea of a template literal. So instead of just having string literals, we actually have a way of defining a template that shows how we want the output to appear and has slots in it that we can use to plug in individual values. So here's a new version of this that uses this mechanism. So let me just go into this cell, and I'm going to hit Shift Enter again. And you notice that I get the same output here from this code block as I did from previously. And the strings being generated now are just this one nicely formatted string. You can see it says customer, and then paren since, and then close paren are all directly in the code as a template. And then the template also includes, you could think of these as placeholders that are filled in by the values from elsewhere in the code. So just like we had up here, customer.first, that was referring to the current customer that we are iterating over, we've got the same kind of iteration here. We're looping over customer list and assigning each value to customer. And then each time through this loop, we're reaching inside that customer object and grabbing the first name, the last name, and the year since they've been a customer. And in order to get the template literal mechanism to insert the values of those expressions, we wrap them up in $curly. So $curly customer.first and then a close curly, $curly customer.last and a close curly, $curly customer.since and a close curly. So the interpreter now is going to look for these $curly, close curly sections of the template and treat what's inside of them as a JavaScript expression. It's going to evaluate that expression, convert it into a string if it's not already a string, and replace this whole chunk of template code with that value, right? So this can be an arbitrary expression. You can call functions, you can refer to literals, you can refer to variables. In this case, we're just referring to a property of an object. It's going to grab that property and it's going to replace this whole thing, including the dollar curly and close curly, with the value. So you can see how that shows up here as Fred in the first iteration and Zelda in the second iteration. So I think you'd agree that this is a lot clearer, a lot easier to sort of write, a lot easier to get right when you're trying to come up with a very specific format for output. Again, this thing, because I'm not returning an explicit value here, it comes back with a value of undefined. And finally, the important thing here to distinguish an ordinary string from a template literal is the use of a different quoting character. So in JavaScript, you can use single quotes or double quotes for string literals, so using exactly those characters. But for a template literal like this, you use a back quote. So there's a back quote at the beginning of this string and a back quote at the end of this string, and it's that syntax that triggers the substitution behavior that I've described. Okay, so those are much simpler ways of constructing strings inside of a JavaScript program. And if you're ever tempted to do some string concatenation, stop, take a breath, and write yourself a template literal instead. A second feature of modern JavaScript is something called a fat arrow function, and we'll see why they're called that in a second. But let me motivate this a little bit. We've been mentioning the notion of asynchronous JavaScript and how important that is in modern web development. One of the ways, actually kind of the fundamental way to create an asynchronous function is to pass to the JavaScript runtime environment a function that will be run sometime later. So for example, if we're trying to deal with a request that we're making over the network, and we don't want to have our user interface just stop working and wait for the network to respond with a request for an image or data or something. What we do is we issue the request to be sent across the network, and instead of waiting for it to come back, we tell the JavaScript runtime, when the response comes back, execute this code. And this code part is what's called a callback. It's quite similar to what you probably saw in 143 with regard to event handlers for user interface components. When you created an event handler for a button press or something like that, you supplied a function that gets called in response to the user clicking on that button. It's the same thing here, only more general, because you can now attach code to be invoked in response to a variety of other events like a network request. So it turns out that when we're doing development using a lot of asynchronous JavaScript, we're very often passing a function to another function to tell JavaScript what to do when something completes. And if we have to use the complete function syntax with the function keyword and the name of the function and all that other stuff, that tends to just kind of get cluttered and causes more work than is really necessary. And one of the reasons that the fat arrow function was introduced into JavaScript was to make that process a little easier and more concise, and once you get used to the syntax, arguably a lot easier to understand. So that's kind of the point here. ES6 fat arrow functions simplifies passing functions to other functions, usually for a callback. So I want to start out here by bringing in some helper functions or defining some helper functions. We're going to have some information here that's going to show timing of different statement execution. Excuse me. In order to get the timing information, I'm going to bring in an external package called moment. Now this require keyword might be new to you. This is actually how we make use of modules that are part of the Node.js ecosystem. So when we want to bring in an external module from Node, or that's part of the very large collection of modules that are available for Node, we're going to install that module on our machine, and then we're also going to have to bring the module into our program. So in a way, this is quite similar to any other kind of import statement that you've used in other programs or other programming languages. We install this moment module, and then the require statement brings it in and makes it available to us. And in this particular case, I'm just importing it as an identifier called moment. So that moment, the moment that I've got selected here, is an object that is going to allow us to access the functionality within the moment package itself. And we're going to spend a lot of time this term using Node and using Node modules and stuff. So if that's not something that you've done previously, don't sweat it. We're going to have an opportunity for you to practice that a lot. Okay, so moment is a class constructor that exposes a whole variety of different functions, one of which basically just gives us the current time. So here in this first function that I've defined here called accurate time, I've got a reference to that moment class, and I'm calling it as a function. So this is how we basically construct a new object in JavaScript, right? We invoke the class, the constructor, or the class itself to construct a new object of that type. What moment does when you create a new moment instance is it grabs the current time from the real-time clock on the computer. So it knows what time it is essentially at that moment. And then the format method is defined by moment, and it takes a formatting string that allows us to ask for the current time to be formatted in a particular way. So this is hours, minutes, seconds, and then the capital S's here give us milliseconds. So we get basically a millisecond timer here by having access to this accurate time function. And just to show you what this actually shows, down here in this next cell, I'm now having defined that function up here. I'm now going to invoke that function. So hit that, and it says, so at the moment that I hit that shift enter, it was 11:29, 33.454 seconds. So we get timing down to the millisecond, which is helpful. I don't want to just grab the time. I also want to be able to print a little message because I want to show some timestamps essentially as we go. So I've got a second function called time message that uses this accurate time function, and it creates a string that has the time and then some sort of text message. So let me show you how this works. I'll just shift enter here, and you can see it's now a minute later. So or half a minute later, as of 11:30:08.351, we generated this message hello moment, and you can see that that's the argument to this time message function. So this is a function that actually just makes use of that template literal mechanism that we saw before. So instead of having to do a bunch of concatenation, I use the back quotes to indicate that I have a template literal instead of just a string, and then inside the template literal I use $curly and close curly, $curly and close curly to evaluate these two expressions. And I intentionally am saying expression there because this can be any sort of a JavaScript expression that returns a value. In the case of the second element in the literal here, it's just the value that gets passed in as the message parameter, which in this case was hello moment, and that's what showed up down here. But in the first instance here of a substitution in the template literal, I'm calling that accurate time function. Notice the curly braces to actually invoke this guy. So when this console.log executes, as part of evaluating this template literal, JavaScript is going to invoke this function, giving back the current time as of that moment, and then appending to that the message that is output here in the demonstration here. So we're going to use that function to show you kind of how some of these asynchronous functions work and how the fat arrow function works. All right, so let's take a look at this functionality from the point of view of just using a traditional function. So we're not using a fat arrow function yet, just a standard JavaScript function. You are probably, hopefully, familiar with the built-in JavaScript function called setTimeout. Now what this does is it tells JavaScript, I would like you to do something for me sometime in the future. And so I've got to give JavaScript two pieces of information. What do I want it to do, and how far into the future do I want to do it? So in order to tell it what we want it to do, we give it a function. So the first argument to this setTimeout built-in JavaScript function is itself a function, okay? And the function here, so it's an ordinary function. This happens to be an anonymous function. I haven't given it a name here, although I could. Its job basically is to call this time message thing that we just saw, right? So basically what it's going to do is it's going to, when this function runs, it's going to go grab the current time and print out, again, string literal, callback, and then it's going to also include whatever value gets passed as this argument to the function, okay? So that tells the setTimeout function what we want it to do. And then the second thing we want to tell it is when do we want to do it? Well, the second argument is defined to be a delay expressed in milliseconds. So this is 1.5 seconds, and we're saying to JavaScript, wait 1.5 seconds and then run this function and do whatever it tells you to do. A third argument that you can pass to set timeout, which is optional, and we're using it in this case, is a value that we want to pass to this function when it gets called. Now this isn't super interesting because I'm just giving it a literal string here to pass in, but it at least illustrates the idea of how do you pass a function to this guy at the time that it's called. Okay, so stepping back to the top level of this little snippet of code, I've got a function called traditional callback, and it's going to do three things. It's going to output that time message thing. In other words, tell us the time at which this statement was called, and it's going to indicate which was which by saying before. Then it's going to do that set timeout function, and then it's going to call time message again at the end here, at which time it'll tell us when it's going to print after. Now, take a second here to think about what's going to happen here. It may be that you think that what's going to happen is that we're going to, and ask yourself what we're going to see in the output. It seems kind of intuitive in a way that we'll see before at some time, and then we'll see callback at some later time, and then we're going to see after at a still later time. Right, so the kind of the naive, I'm giving it away, the naive expectation here is that we're going to see before, callback, and after in the output. So let's see what actually happens when we call this function. Notice here at the end of this cell I'm actually calling the function, so we'll get in the output from the Jupyter Notebook the details of these time message functions. So Shift Enter. Now I'm gonna run that again, and I want you to just kind of keep an eye for when things show up in the output. You see how we get before and after almost immediately, and then after a delay we see callback. Let me run it one more time. So in this case, the timestamps for the before and the after are they're identical here, although we know there was a little bit of delay there just because we know something happened behind the scenes. But within the resolution of our millisecond timer, they look like they happened basically right at the same time, although before showed up ahead of after. And then there was a delay, and then we saw this callback. So what's going on here? Well, this is our first example of asynchronous JavaScript. What we did in our traditional callback function was we executed this function call synchronously, right? As you think about kind of the execution stepping through the source code here in the implementation, we're going to call this time message function. That's going to invoke the function that we defined up above, grab the timeout by calling another function we defined, which calls another function from the node library moment, and all returns back and formats a string, and we see that show up here. The next statement that's executed when we run traditional callback is this set timeout. But the set timeout function, as I've said, causes this function to be executed after some delay, right? So if we look at the timestamps, we would expect that this output to show up about 1.5 seconds later, 1500 milliseconds, and you can see it's just slightly longer than 1500 milliseconds, right? If we add 1.500, we would expect to get a slightly different value, but it's almost within 4 milliseconds. It's about the right time. And that's this example of asynchronous behavior. We've told the JavaScript runtime engine, hey, after a second and a half, run this function, and the JavaScript runtime goes, fine, I'll sort of stick this on the back burner and wait for a second and a half, and in the meantime I'm going to go ahead and continue to run your synchronous function here. So we see before, we tell JavaScript to get ready to do this a second and a half later, and then we immediately execute this statement, time message, with the after prompt, and those things come out pretty much immediately, right as soon as we execute the function. Then And you'll notice here that everything continued to run, right? I've still got JavaScript functionality here in the notebook, although there's some subtleties to what's going on here. But if this was in a web page, everything would continue to operate as normal, and then suddenly a second and a half later, this function would get called and do whatever it does. And that's exactly what we see here in the output. We run these two things, we wait you can see actually that this undefined, that's actually the output from this entire cell. So by the time we get to undefined here, we've actually executed all this code, and this traditional callback invocation has returned to us, right? So if there was more code after this, it would have continued to continue to execute synchronously, and then suddenly, boom, this asynchronous function executes after the timeout expires. Okay, so that's kind of the fundamental behavior that we expect to see when we're doing asynchronous function calls in JavaScript. We tell it, at some point in the future, I want you to run this code. Now in this case, by some point in the future, we mean a specific time. But it's equally valid to tell JavaScript when a key press is made, or when a button is clicked, run this code at some point in the future. Or when a network request has a response come back to the browser, we can say run this code when that network response comes back, and use that information to say fill out the contents of the user interface. So that's the general pattern. We're telling JavaScript, and in the future, in response to some sort of event, whether that's a timeout or a user interface element or a network request or whatever, run this code. And in the meantime, continue to go about your business running the rest of this synchronous function. Okay, so this would be completely fine in most cases to just use the traditional function notation, but because we're going to be doing this a lot, it turns out to be more convenient to use a slightly different notation that is mostly identical except for a couple of subtleties that I'll mention here at the end. So these things are called fat arrow functions, and they're so described because they use this equals greater than symbol, which is a fat arrow, as opposed to hyphen greater than, which would be a skinny arrow, I guess. And that's what signals the fact that we have a function going on here. So we don't use the function keyword like we did up here. We just use the fat arrow. So the equivalent of what we've just written up here in terms of the traditional function call, using a fat arrow is almost exactly the same. So everything is the same here except for the name of this function and what's going on here. So that's a fat arrow. And if this is new to you, the strategy I'd recommend is just whenever you're looking at a new piece of code in this course, or whenever you're thinking of writing a new piece of code and you want to use a fat arrow function, just scan for the instance of this greater or equals greater than symbol. If you see that, you should just immediately say function. Okay, so equals greater than, think it's a function, because that's what it's defining. Now, just like in a normal function, functions have kind of two main pieces, right? The list of arguments that you're going to pass to the function, and then the function itself. And you can see here in the syntax for this second example, there's the fat arrow. To the left of the fat arrow is a list of arguments. In this case, it's just a single argument called arg, just like up here. And then to the right of the fat arrow is the function itself. And in this case, we're using just the standard kind of function body notation, right, with the curly braces and then the function that we're calling inside of our function. It's exactly the same as what we had up here, right? So in a way, you could see that all we're doing is kind of taking away this function keyword, and we're sticking a fat arrow in here, and that's what's changed, okay? So far, not obviously a really huge win, but we'll see that actually gets even more concise, which is very helpful. So we've now defined a new function, fat arrow callback, that still uses the timeout. It still waits 1500 milliseconds, and it still calls a function. It's just that the syntax that we're using to describe that function is slightly different. So let me go ahead and execute this code block, and if you keep an eye on the timing and the way that things pop out on the output, you'll see the same behavior as previously. And there we get the callback. So before and after came out right away because we're walking down this function synchronously, hit the time message function, output stuff, hit set timeout, prepare to do something in the future, hit time message function, output something immediately. And then we see that the cell actually returned with the undefined return value. And then a second and a half later, we got the output from the asynchronous function, this time defined with a fat arrow function. Now, as I said before, this doesn't seem like a huge win in terms of syntax and whatnot. It turns out we can simplify the use of the fat arrow function. So here's the version of that function that we were just using. The arguments are in parens. We've got curly braces around the function body. We can simplify this. If there is exactly one parameter, right, here we have one parameter called arg, we can lose the parentheses. So here's something that's semantically identical and syntactically simpler. So we've got a single argument, we can lose the parentheses. I've still got the curlies, I've still got the function call. This does exactly the same thing with fewer characters. Furthermore, if there's only one statement, as in this case, we're just calling this one function, we can eliminate the curly braces. So here's, again, a third way of writing this fat arrow function. We can write it as explicitly as possible. If we have a single argument, we can eliminate the parentheses. And if we have just a single statement in the body of the function, we can eliminate the curly braces. Okay. And what we'll see as we go, trust me, is that we're going to see this kind of a construct a lot as we're using asynchronous JavaScript in this course, and you'll see this throughout your career as you do web development. So we can finally settle on sort of this final version here. Within that set timeout, that's the JavaScript thing that says, hey, tee this up to run at some future time. Here's my callback function now. I've eliminated I've eliminated the parentheses around the single argument. I've eliminated the curly braces around the body because I have only one statement in the body or one expression. And I've also kind of collapsed this down to make it a little bit more concise. In the previous examples, I was trying to show you the details of how this thing nested to make it a little clearer, I hope. But in this case, right, we just have this nice, concise single line that says, after this amount of time, sometime in the future, call this function, and oh, by the way, pass this value to it. So when I call this guy, we'll see again similar behavior. A little delay, and then finally we see the callback showing up. So we're going to use this a lot. But again, the thing to keep in mind here, the thing to hopefully help you avoid confusion over this new syntax is just keep an eye out for those equals greater than symbols. That always should trigger in your thinking, hey, that's a function. On the left-hand side of the fat arrow is the argument list. On the right-hand side of the fat arrow is the function itself. And then once you've identified that there's a fat arrow function there, you can use those shortcut ideas to give you a clearer picture of what's there. So if you just see a single identifier without any parentheses to the left of the arrow, that's the argument, right, and so forth. Now there's some subtleties here that are good to keep in mind. One of the things that well, if we step back a second and ask yourself, if I have a function in JavaScript and it just falls off the end when it's executed, what does that function return? Right? If I don't have an explicit return statement in a JavaScript function, what does the function return if it just runs to the end? The answer, if you think about it for a while, the answer is actually it's going to return undefined. That's just the way that JavaScript is defined. If you don't return something explicitly from a function, there's nothing for it to return, so the so-called value that you get back is just the value undefined. As we've been seeing this, like in this example here, the Jupyter Notebook is actually getting an undefined value back from this code snippet because there's no return statement here. Now, in many cases, that's perfectly fine, right? In the example that we've been showing here for set timeout and whatnot, we don't really care what value comes back from the function that we're passing as the first argument here. We're really only doing this because we want to have it give us this side effect of printing something out to the console. So we don't care about the return value. But in a lot of cases, we do care about the return value, and we'll see in a couple of days that we can use these fat arrow functions in a way that allows us to do several things kind of in sequence, right? Grab a value asynchronously, send it over the network, get something back from the network asynchronously, and so forth. And as we do these things kind of one after the other, in many cases we want to get the return value from the previous asynchronous function to use in the next one. And so what we would normally have to do in a regular function is include a return statement in that regular function. That would give us a value back. In the case of a fat arrow function that's been kind of used, or that's using this simplified syntax that doesn't have curly braces and stuff like that, the thing that's here on the right-hand side of the arrow is just an expression. It's not, it wouldn't permit us to put in, well, it would be awkward for us to try to figure out how to put in a return statement there. So in a fat arrow function, the behavior is slightly different from an ordinary function. An ordinary function without a return statement gives us back undefined. A fat arrow function, because it's almost always used in this context, will give us back the value of that single expression. Okay? So if we don't have curly braces and we only have a single statement in the fat arrow function, the value of that single statement is what the fat arrow function is going to return. Okay? So that's what I'm after here with the return value. With curly braces, behaves just like an ordinary function. If we want to return something, we need a return statement. Without curly braces, the fat arrow function, well, and again, without curly braces, there can be only one statement in the body of the function. Then the fat arrow function is going to return the value of that statement as its return value. And that turns out to be super helpful later on. So if that's not quite resonating with you yet, don't sweat it too much. You'll see how that's used before too long. The other thing that's different with a fat arrow function is the way the this keyword gets handled. This is, it's hard to say this, the this keyword is much maligned in JavaScript because it sort of behaves in goofy, context-sensitive ways. And there's a lot of articles out there you could dive into to learn more about that. But what happens in a traditional function with the function keyword and the curly braces and stuff is inside that function it sort of redefines what this is, which can be helpful in some cases, but is widely thought to be sort of a design flaw in JavaScript, in particular because it shadows any use of this in the scope outside the function. So it has some unexpected behaviors when you're coding and using this for anything but sort of trivial things. So there's some ways to hack around this, but they're generally frowned upon. The fat arrow function, in addition to just kind of this simplification of the syntax, actually changes the way the way that it uses the this keyword. So if there's a value for this in the enclosing scope, it has the same value inside the fat arrow function. Okay, so this is unchanged by the function itself. Whereas so traditional function, you get your own version of this, and you have to work around that if you need to have the enclosing scopes version of this. Fat arrow function doesn't create its own this; it just lets you use it from the enclosing scope. So if you have something like this example here, if the value of this was something meaningful elsewhere in your application and you wanted to refer to it inside of the function, you can just go ahead and use it. Whereas if you're doing that inside of a traditional function, it requires a little bit more finesse. Again, if that's not super clear to you, or you don't have direct experience being bit by the this problem, don't sweat it too much, but I just want you to be aware of these two subtleties. The return value is going to be something that's really important, and we'll see that this turns out to be really handy because it sort of restores JavaScript function to kind of more sane behavior that we expect from other programming languages. And I put a link here in the notes to an article on Mozilla Developer Network that goes into more detail about arrow functions. If I haven't mentioned this already, Mozilla Developer Network is a super helpful resource for all things JavaScript. They've got lots of great kind of tutorial level stuff, reference material, more advanced articles once you sort of get into the details of some of these things. It's definitely a website to have in your bookmarks and that you go to regularly to get a handle on some of the subtleties of how JavaScript works. So I'm going to post both this video, and I'll also post the notebook itself, and then I'll also post a printed version of the notebook so you can refer to it as you go. If you're interested in using Jupyter notebooks, I think they're really cool. They really help a lot with kind of prototyping and just experimentation and learning. Let me know, and I have a Jupyter server that's set up in the department. If you want to use that, I can make you an account on there really easily. It's also super simple to install it on your own laptop or desktop. If you'd like to do that, just go to the Jupyter website that I showed you before, and there's instructions there. It's basically just, if you have a Python installed, you run one pip install command and you're done.